Finally here we're going to look at odds in this section. We're going to be looking at the odds in favor of an event and the odds against an event. And they're basically calculated using probabilities. The odds in favor of an event are the probability of that event divided by the probability of it not occurring, okay, not that event. And then of course the odds against an event are just the reciprocal of that fraction, the probability of it not occurring divided by the probability of it occurring. And so just to give you an example of how this plays out, the odds in favor of drawing a face card, that can be calculated simply by computing the probability of getting a face card, which is, what did I say, there's 12 out of 52 cards in a deck that are face cards, right? 12 out of 52. And 12 out of 52, you can always reduce these, although I may hold off on reducing these because I might like the canceling of the 52 in a moment. The probability of not F, well, how many cards in a deck are not face cards? Well, take the 12 off, you get what, 40? There must be 40 cards. Ace, 2, 3 up to 10, so that's 10 cards per suit times 4 suits, that's 40. So 40 out of 52, okay? So now the odds in favor are calculated by taking the probability of F divided by the probability of not F, which is, you know, I'm interchanging some notation here. I just want to be careful. It's really not appropriate. I'm using the negation symbol for logic, for the negation of a statement, rather than the negation of a set. I'm really confusing a couple different notations. What I really should be saying is the complement of a set. Your textbook actually uses the word not in there, which is fine, but I don't really care to write that. I would rather write, I should be writing F complement, F prime, and using the actual set notation. So let me switch over to that. Really should have been doing that from the beginning, but I was just trying to be a little bit more consistent with the book using the word not and then just shorthanding it, but that's really being sloppy. So I want E complement. Yeah, that's better. So here I want F complement. That's a little bit better. I like that. So yeah, so go back, you know, if you think about this in the previous videos I did on with the knots and the ors. When we did the knots, just make a note of that. Those should be complements, or the word not E or not F or whatever they were. All right, anyway, odds in favor. In this case, you're going to take the first probability, which is 12 over 52, and you're going to divide that by the second one, which is 40. Oops. Just try to be consistent with my notation here. 40 over 52. Well, divided, this is really a fraction within a fraction, two fractions within a fraction. So we're going to copy dot flip. We're going to multiply by the reciprocal of that second one. So we get 12 over 52 times 52 over 40. Again, I chose to not reduce those because I knew ahead of time there's going to be some canceling going on. And so I would cancel the 52s immediately. And then the 12 over 40 can be reduced further. So we get 12 over 40. You can definitely take a 4 out of each of those, and that'll give you a 3 out of 10. So you get a 3 to 10 odds of drawing a face card, all right? And the way that we usually represent that is we write that the odds with a colon separating them, or we say 3 to 10. That essentially means that there are 3 ways to get a face card and 10 ways not to. So the odds in favor are 3 to 10. Now, if I wanted to reverse that and do the odds against, it's the reciprocal of the original fraction, which ends up simply reversing the order of the two numbers there. So I'll do this in red. The odds against would start off as the probability of F's complement over the probability of F. I did E. Why did I do that? So used to writing E there. Which is, of course, the reciprocal of this. 40 over 52 divided by 12 over 52, which, of course, ends up being 40 over 12, which reduces down to 10/3. And you get a 10-3 odds against getting a face card. Okay, so again, you're looking at, you're basically looking at, in the odds in favor, you're looking at the number of ways you can get the E or the F or whatever the set is, the number of ways to get that versus the number of ways you can't get it, okay, or not getting it. So there, in any suit, there are 3 face cards and 10 non-face cards, right? If you were just thinking about this in terms of the whole deck of cards, you could go 12 to 40 and then think of it as a fraction, reduce it down 3 to 10, okay? So there are 12 face cards in the deck and 40 non-face cards in the deck. And then, of course, the odds against are just the reciprocal, or in this case, the reverse of the odds in favor. And then finally, we can also convert the other way around. We can go from the odds to the probabilities, which is kind of interesting. And it's because the why was I going to say that? Oh, it's because when you get to this 12 to 40 idea, before you reduce the ratio, before you reduce the fraction, if you think about this in terms of 12 to 40, well, the probability of actually getting the event, getting the face card, is 12 divided by the sum of 52, right? So, so the probability here of getting F, getting a face card, is 12 over 12 plus 40, right? That's 12 out of 52 cards. So you add them together to get the total. You could also do that with the simplified form because it's just going to give you the reduced fraction, right? So here I could add those up, 12 over 52, which reduces down to 3/13, 4/13, 3. Yeah, 3/13. Sorry. So you could also do this in terms of the reduced odds. You could look at this as 3, oh, there it is, 3 to 10. And so the probability then is the 3 over the sum of 3 plus 10, which that one reduces down to 3/13. Okay. So this one is 3/13, this one is 12/52, which reduces to 3/13, so the probabilities are the same. All right, so as a general rule, you can kind of go backward. If you know the odds, you can construct the probabilities, and in fact, if the odds are in simplest form like they should be, you can actually go directly to the probability in simplest form simply by taking the first value, putting it on top, and then adding the 2 and putting them on the bottom. And that will give you the probability of event E. So, if I erase this, I can summarize that. If the odds in favor of E are A to B, right? So in this case, it'd be like 3 to 10. 3 is the A, 10 is the B, whatever they are. Doesn't matter. Now I can be arbitrary with these. I can use variables because it doesn't have to be a specific 3 to 10. It could be anything. If the odds in favor are that, then the probability of E is simply A over the sum, A plus B. right? So you just add them together on the bottom. And of course, if you wanted to go the other way, if you had the odds against, then you would just take you would put the b on top and divide by a plus b, right? So odds in favor can convert to a probability by taking the first number and putting it over the sum.